Let's work some conceptual problems for momentum and impulse. For a constant force, suppose the impact time is doubled. How much is the impulse increased? Remember, impulse is Ft. So if you increase t by a factor of 2, then you're going to increase I by a factor of 2. So the impulse increases by a factor of 2. How much is the resulting change in momentum increase? Impulse equals change in momentum. So if impulse increases by a factor of 2, the change in momentum will increase by a factor of 2. In a car crash, why is it advantageous for occupants to extend time during which collision takes place? Well, impulse equals change in momentum, and you remember in any car crash the change in momentum is the same. It's going to equal your initial velocity times your initial mass, so this is a constant. So this is a constant, and so this is equal to Ft. So you want to increase the time to decrease the force, because that has to equal a constant number. What's the difference between elastic and inelastic? Well, remember this. Elastic bounces. Inelastic sticks. Remember your verbs. Be is. Elastic bounces, inelastic sticks. Now, suppose I have a mass, m, moving at some velocity, v, and it collides inelastically with another mass, 3m, which is initially at rest. So v2 is 0, while I've got over here v1 is something. It's just v. And so I know this is 3m and this is m. And this whole thing's going to move off with some final velocity. Now, the total system mass in motion, how much is moving? Well, in the first part, before collision, I have m moving, while after collision, I have 4m moving, which tells me the total system mass is going to increase by a factor of 4. Now, let's find the velocity. Let's just read off our conservation of momentum. M v1 plus 3m v2 is equal to 4m times v prime. Now, v2 is 0. Masses cancel. So v prime, so hold on. So 4v prime is equal to v1. So the velocity of the system has to decrease. Let's find out by how much. V prime is 1 over 4 v1. Has to decrease by a factor of 4, and the new velocity is going to be 1/4 of v1. This is just a little bit of analysis. What if we change the numbers a little bit? We have mass m moving at velocity v, and it collides with a mass of 4m, which is initially at rest. We have our collision, and let's see, it's inelastic, so they stick together. This is m, this is 4m. So my new mass is 5m, and I'm moving off with some velocity. So I've got m times v1 plus 4m times v2 has to equal 5m times v prime. But this term is 0. So I have m times v1 has to equal 5m times v prime. Masses cancel. V prime is 1/5 v1. All I did was divide through by 5 here. So I The total system mass is going to increase from m to 5m. Now this is just what's in motion, because the whole system mass actually doesn't change. So this increases by a factor of 5. The new system decreases by a factor of 5, and the new velocity will be 1/5 the original velocity. Do you see that relationship there? It goes from 4 to 4 times the mass to a quarter of the velocity. When we increase the amount of system mass moving by a factor of 5, the final velocity in an inelastic collision decreases by a factor, is 1/5 the original velocity. Now, let's look at this one. I have 3m collides with a velocity v, so I have 3m moving at velocity v, collides inelastically with an object of 4m, which is at rest. So, the total amount of system mass in motion will increase by a factor of, okay, let's draw this out, 3m, 4m, so this is 7m. My total mass moving afterwards is 7m. So, let's see. I end it with 7m moving, but I start it with 3 moving. So the system mass in motion is going to increase by 7/3. Let's find what the velocity is. 3m times v1 plus 4m times v2 has to equal 7m v prime. v2 is 0, so that goes away. So v prime is 3m times v1 divided by 7m. That goes away. So this becomes 3/7 v1. So the velocity of the system is going to decrease by a factor of 3/7.